Hi, in this video I'm going to explain why you are forced to deal with this CIM stuff. I know from experience that when you start working with data models that are modeled around the CIM standard, many team members might feel a little like, why do we have to work with this complex old stuff? Because of course it adds, you could say it adds a certain level of complexity to the modeling part of the system, because the CIM standard has a way to kind of divide things up. And the CIM standard itself is very big and actually complicated. So in the start, when you begin work with CIM, and before you kind of understand its power, you might be a little frustrated by it. That's the way it is. But when you begin to learn how it works and begin to get the different concepts under the skin, you'll be very happy by it. Because what CIM does is it divides things up. It divides the complexity up, as I will show in some other slide, and that makes it much easier to avoid that the system becomes entangled mess that no one can maintain anymore. Because basically what we see out there today with the existing systems for handling fiber optical network models in the GIS, that they are very, very difficult to maintain and very, very difficult to extend, and are very, very expensive to operate, because everything is like built like from the start, like it's built with no vision in terms of how do we handle all this complexity that will come. I mean, if the system is used, the complexity will sure come. There will be more and more features, there will be more and more team members going to work on this system. And if you have not kind of created a strategy for handling this complexity so that the project can scale without being a very big mess, where everybody is stepping on each other's toes, if you don't have a strategy for that from the start, well, we will end up with a system like the ones already exist out there. And that's not the idea, because the customer, of course, will not use our system if they can use the other system that's already proven and maybe used by a lot of other utilities, if our system is not any better. So we have to do the job better. And one way to do that is to utilize the CIM standard. So, yeah, you probably never heard about the CIM standard before. Not many know this standard unless you work in the power utility domain. And the CIM standard is basically it was a frustration by some IT people working with systems in the power utility world, as SCADA systems and stuff like that. And they have very difficulty to integrate these systems with each other. They have difficulties to get rid of old systems and buy new ones, because they were very closed, and it was like black boxes that have their own data models and so forth. So they started to create the CIM model. That's a long time ago, and today it's widely used in the power utility world when systems are created, and it's a CIM standard that is many times forced onto the vendors, so to kind of prevent them to create something that cannot be integrated with other systems. So that's how the CIM standard started. But what's really nice about the CIM standard is that most of the stuff, at least in the core model of CIM, is stuff that can be used, no matter if you're using power grids or fiber optic grid or whatever type of grid you're operating. There's many concepts in there, like asset management, work management stuff, and modeling, network modeling stuff that we can reuse. So that's what we're gonna do. Okay. So hope that's enough of a general introduction to CIM. Otherwise, you have to look it up in on the network, sorry, on the internet. I also will probably use some links, I think, in some of the slides. Okay, let's go on. The main thing we're gonna use from CIM, if you look from a helicopter perspective, is that the standard is dividing information or dividing information models up into several models, basically. You could say several packages that are quite loosely coupled. So I have written here 4 different data models, or you could say packages, or I don't know, separation of concerns that is very vital to understand. So when you begin to look at the solution, you begin to look underneath the hood, you'll see in database and so forth, there will be some entities or tables or classes that will belong to the equipment world. So they will actually be prefixed with equipment. So you can see easily this is equipment stuff. And then there will be some tables and entities that are related to asset information, or just asset, like serial numbers and so forth. And there will be some entities related to what we call asset info. This is the name in CIM used for type information, catalog information. And there will be some related to work management. So you can say that the system will kind of be divided into these different data models. And this is really, really a big help when the system begins to become more and more complex and used in real life. Because by dividing things up like that from the start, we prevent a lot of problems that the existing system have. Because the usual way these systems are built, these GIS systems, is that you create some kind of feature classes or tables in a database, and you fill in stuff on these when there's a requirement for different kind of stuff. So maybe you start creating some, let's say, a class that's called fiber cable or whatever, and then someone can say, oh, we need to know when it has to be maintained and who has worked on it, and you put some extra attributes on it that tells who has maintained it or who has been there, and so that's basically work management stuff you put on the same table. Maybe they say, oh, we need to know the serial number of this stuff, you need to know blah, 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 so you put some more attribute on that table, and so forth. So you'll end up with what we call a fat class, basically. So it's a table with a lot of information on a lot of attributes, and no one can figure out what attributes are used by who, and it gives an awful lot of problems because you are mixing things up in the same entity. So, for example, there will be some information that belongs to the network function itself. So that, okay, this cable goes from here to here, it's connected on this and this, and there will be asset information that belongs to the world of asset. So, for example, someone go out there and replace that cable with another one. It has the same function in the net, but it's replaced because maybe someone dig it over, pull it out of the pipe, blow a new one in, connect it. So it's another asset, right? But then, because you have everything filled out in the same table, you get a lot of problems. You have to kind of optimize, update all kind of fields and stuff like that, and it's really difficult to see what has happening to that record. So you basically screw up your asset management function of the system. And same goes for work-related stuff. So that's why it's so extremely important that we divide it up like this, because in not long, not much functionality has to be put into this system before this makes a lot of sense and makes life easier for the developers to create something that gives value to the users, because it's much easier to scale up things. So, and I try to kind of explain down here why we're going to do that, and the reason I'm going to use the CIM way of doing this is because people in the CIM community, they already did a great job of defining these fundamental bounded contexts. So there's no need that we reinvent the wheel here. We just basically snatch the idea because we know it works. And that's of course because we don't have the resource to create a better model. It has millions of man hours put into these models in CIM. So, and it's have been refined, and they have been, I mean, we cannot compete with that, so we're going to use that. But however, of course, we want to optimize that model. So when we begin to kind of get smart, and there might be some things in the telco world that maybe is a bit different than in the power grid world. So we maybe need some extensions and so on. So of course we're gonna evolve that model, but the fundamental principle behind it we're gonna reuse. Okay, so that's the idea. Yeah. This is again actually this slide kind of talks about the same thing I just talked about. Here I want to kind of tell you a little about, if you want some more information about this and why this is important, I can recommend you to look at some of the links here. One of the things I like to kind of I like to emphasize here is that the concept of bounded context. And I'm going to click this one, then it's easier to explain it. Martin Fowler, very famous software engineer, he has this his web page where he describes the most known patterns and stuff. And this is his description of the bounding context. So say bounding context is a central pattern in domain-driven design. It is a focus of DD strategy, design, section is all about dealing with large models and teams. DDD deals with large models by dividing them into different bounded contexts and being explicit about their interrelationship. So this is actually what CIM does. So it has some kind of equipment model. For example, it could be this, and it has the asset model could be this. And of course, they are tied together, but they are separate and maintained separate. So this is just by doing that division between equipment model and asset model. I'll talk about more about that in a moment. You have solved a lot of problems, and the system will be much easier to evolve. Okay, so this gives you a basic idea why we're going to do that. Okay, I throw this book in here from Frederick Brooks. I'm not saying you should read this book, but I have a kind of special relationship to this book because I actually read it when I was like 20 years old. It was an anniversary, I cannot pronounce that word, version of it that was created 20 years after its original version of this book. The book was created in 1974. It's actually where I was born. And in this book there was a lot of concept defines. And it's like, I mean, this is a kind of problem we also fight with today that was already talked about in this fantastic book. And one of the things that is really important that Fred Brooks talked about in this book is something he called conceptual integrity. And this is basically what we're going to try to do here, that we try to kind of create a system where there is a conceptual integrity in the way that things are connected, modeling-wise. So we are able to kind of add things on, put more and more complexity on, and still be able to kind of understand how the thing works. You cannot do that unless you have this kind of these bounded contexts I just talked about. It's impossible. You cannot scale up. The system will eventually be a system that no one wants to touch. Okay. So this book is kind of where I started to begin to be interested in this kind of problem, because before this book I have just read book about programming language and stuff like that and technologies. But actually these kind of things here is maybe I would say more important, but that's just as important as the technology to create systems that are easy to maintain and that will give a lot of value to the business users. So another book that is much more new is the domain-driven design book by Eric Evans. I think it's, I don't know, 10 or 15 years old, also known as the Blue Book. And again, I'm not saying you should read this book. maybe there's better book out there now, but he was a kind of the pioneer in terms of that concept called domain-driven design. He was the one who talked about the bounded context and so forth. And it kind of makes a lot of sense to use some of the principles from his ideas, because you will, the system will be much better. And unfortunately, many of the systems made today, no one cares about this stuff, and they just have to be built as fast as possible. You put a lot of teams to build on it, and you create a lot of user stories and stuff like that, but you forget to kind of focus on the domain and understand the domain and get the domain divided up. And if you do that, you will not come that far, and you will get into trouble. I've tried it so many times. So this book kind of started a community of people that kind of understood the importance of this domain-driven design approach. Regarding the book, I will say that it's a bit dry in this book, and also this guy is a bit dry. He's a genius, no doubt about it. But I know many software developers who read this book, they will not come through it. And I mean, so maybe there's some book out there that's more easily get you up to speed with domain-driven design. But if you really want to know the kind of source of it, many of the ideas, it's in this book. And the chapter on bounding context actually is in this book. Is one of the chapters that are quite, I think, in the end of the book, and many never come to that one, even that is very important. So he starts to explain a lot of kind of technical stuff, you could say, about aggregates and different kind of patterns you can use when you do software. But the bounding context stuff he explains in one of the chapter, in the end. And I know he had said himself that he should have put that part in the front of the book, because it's so important. So, because if you don't get your boundaries correct, I mean, you cannot get your boundaries 100% correct. It's impossible. But you have to try. You have to try to kind of divide the domain up. If you don't put any effort doing that, you will end up with trouble. So this is the reason. So we're gonna use CIM, because they have already divided the utility domain up. So we're gonna build on that, because we are lazy, right? We don't want to reinvent the wheel. Okay, the last thing here, last slide here, is quite important, I think. I'm gonna explain the equipment model in more details, because this is the one that many is confused about. So what is the difference between the equipment model and, for example, the asset model? Here you have to kind of think that the equipment model is a data model where you can register kind of a description of the functional network. So that means, what function do the network have to do? I mean, it has to provide some services to some customers, right? You have to connect it so it has the capacity to serve whatever we need to serve, right? So this is kind of functional requirement. So what you do is you build a model of that for a start to figure out if you have done everything right. So another way to think of the equipment model is the project engineer or planner's view of the world, right? So you know, doing tasks like new network rollout, capacity planning, signal calculation, reliability analysis, etc. What is needed is this kind of functional view of the network. And this is very important to kind of separate that, because in that phase where you're going to deal with this kind of problem, you don't care about all the other stuff. You don't care about work-related information, like has installed this thing and who's going to install this thing, and so forth. When was it happening, and when is this thing going to be maintained and stuff like that. You don't want to get this view polluted with all that information. Also, asset information, like, you know, serial numbers and stuff like that, who owns that asset, and you know, all that stuff. You don't want to put into this model. You want this kind of pure view of the network function. And the reason you want that, because it's so extremely important, because that's a model you will use to take decisions from, a lot of decisions in terms of designing the network and expanding the network and do different types of calculations. it's you can think of it as an abstract mathematical model, basically, of a utility network. So another thing that's very important to understand about this model will survive all the other models, information in all the other models. So the function of the net, let's say you have some nodes and you have some connection to these nodes and you deliver some service to some customer. This is the function of the net. You might replace the cables, you might replace the equipment many times in the lifetime of the equipment model. But the equipment model is the same. You still have to deliver the same function. So that's why you don't want to mix asset information with this stuff. You have to separate. And when we begin to work with the functionality in the system, you'll also see that most of the functionality, such as replacing an asset, for example, it's much easier when we have divided up things like this. It's more clean and understandable. And also, you can think of it by having a model like this, where you focus on a particular bounded context. You can have a team of developers be very, very good at this model, this part of the system, and create nice stuff for this. They don't have to kind of deal with the other stuff, like asset stuff. They don't have to step the asset people over their toes, because the coupling is very loose there. Okay, that's at least what we're trying to do. It can be hard to keep a loose coupling between these models, but that's what we have to try. Okay, so I know this is probably a lot of ramblings here, but I hope it's a bit understandable. The reason why we're gonna do this, that we're gonna base this on the same model. So that's it. Bye bye.